Module 1, Lesson 24, Triangle Congruence by Angle, Side, Angle Postulate. In this lesson, we are going to prove that triangles are congruent using two angles and an included side. Another editing problem here, fix that. So this is very much like what we just did with side, angle, side. We had an included angle, and in our last lesson we discussed included sides as well. So this is going to be very similar. So the angle, side, angle postulate says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then you guessed it, our triangles are going to be congruent. So let's see what we have here. We have segment AC is congruent to segment DF. Angle A is congruent to angle D. And angle C is congruent to angle F. And you can see here that we have two congruent angles and an included side that are congruent, so all of our corresponding parts are in the proper order. We can write a congruence statement, and this one goes from green angle up to our non-marked angle and then down to blue angle. So we need to go green angle up to our non-marked angle down to blue angle. So triangle ABC is congruent to triangle DEF. Now you know me, I like to make things easy. If I were naming these triangles, I probably would have gone this direction and then up that way. And so I would have said triangle ACB is congruent to triangle, and then it's very easy to write this next one because I went from angle 1 alongside 1 to angle 2, and then only one direction you can go from there, so DFE. But again, it doesn't matter what order these go in. You notice that all of our parts still match up. So let's look at a problem using angle, side, angle. We are given triangles here, and I see congruent angles marked. All three of them have a green angle, and I see other angles that are congruent. All three of them have a blue angle, and we also have a congruent side here. So they all three have a purple side. So now we have two angles, two congruent angles, and a congruent side, but are all three of these triangles congruent? Don't forget, order matters, and angle, side, angle says you must use the included side. So I see that only triangle 1 and triangle 2 are congruent. Triangle 3 does not have the included side congruent. Now it may be, but we certainly cannot prove that here. So we can say that I would name it going this direction to this direction. Triangle UVS is congruent to, and how did I name it? I went 1 to 2, and then down the other side, triangle EON. Now you notice they chose to name it a different direction, but still all of our parts match up. And another example, are these triangles congruent? We do not have enough information. We do not have an included side. No included side. And of course, let's look at some proofs using angle, side, angle. All right, what have we got here? We've got a given side. Those are given. We've got some given angles. Those are given. Now be careful, those look like vertical angles. They are not. Remember, vertical angles have to have intersecting lines. Those are not lines. Be very careful with that. I see some right angles. Do you remember our theorem about right angles? So we are given two of our angles and a set of right angles. So in our Explore, we write angle, side, angle. We know that both right angles are 90 degrees, which means our measures are equal. So by definition of congruence, our angles are going to be congruent. And so here's our green angle. Here's our purple side. And then 2 steps to get our pink angle. Now let's look at our proof. We have our green angle, which was given, our purple side, which was given, and then it's going to take us 4 steps here to make our angles congruent. First, we are given that they are right angles, and then we can say that their measures are 90 degrees, which is by definition of right angle, and then I can simply substitute these together. It might look like transitive, but it's not. It's substitution because they are numbers. And then once my measures are equal, then I can say that by definition of congruence, my angles are equal. Now, if you remember your theorems, we have a theorem that says all right angles are congruent, which would allow us to go straight from we are given that they are right angles to our angles are congruent because all right angles are congruent. So these 3 steps right here, this step, and this step, could all be replaced by simply saying all right angles are congruent. Knowing your theorems can make your life easier. And then we can simply say that our triangles are congruent. And so we have another editing error. I apologize. We were trying to prove that triangle ABC is congruent to triangle AED. We went from one angle downside 1 to our right angle and then up, which makes it easy to go down that side and up. So ABC, AED, angle, side, angle. Again, define, explore, and labeling your diagram makes it obvious that we have angle, side, angle. Now looking at our rigid motions, this one is a little bit more challenging, but hopefully you can see that this is simply going to be a reflection of a line that passes through point A. That would be our line of reflection, and that line would need to be perpendicular to segment EB here. So that would make our corresponding parts map onto each other. So that one's pretty obvious. Now, what could we do for a composition? Well, if we take these 2 triangles here and let's rotate this triangle this way until these parts match up down here. So this would be point B and this would be point E and our common point A here. So if we rotate E until it matches B about point A, this would be our center of rotation, A. So we rotate around that way, and then we could simply do a reflection across line BA here. So that's another option. I'm sure there are many others. Now, of course, our proof using corresponding parts of congruent triangles. We are given these sides, and this time we know that segment AM is the bisector of angle BAC. So I know these angles are congruent by definition of angle bisector. If we are trying to do angle side angle, I see side angle side. Do you see that in the middle there? Our common side, we could do side angle side, but we want to do angle side angle. So how do we get these two congruent? This is our isosceles triangle theorem. We have two congruent sides. That means our base angles are congruent. So that's a lot of fun. So we write angle side angle. And our first angle here is our pink angle. It's going to require our given. We have an angle bisector that is given. And then definition gives us congruent angles. We are given our side. And our second set of angles comes from the isosceles triangle theorem. So we write our proof. Our first angle requires two steps. And then we are given our side. And then our second angle comes from the isosceles triangle theorem. And then we can write a triangle congruence statement. So again, I went down the middle, across the bottom, so down the middle, across the bottom there, and we get triangle AMB is congruent to triangle AMC, this time by the angle side angle postulate, and that lets us prove whatever else we would like to prove about this triangle. We can say that these two angles here, angle AMB is congruent to angle AMC by CPCTC. We could also say that segment MB is congruent to segment. Which direction do we go? MC. Look at your triangle congruence statement. MB has to be MC, would also be CPCTC. And we could also say that segment AM is congruent to segment AM. Look at there in your triangle congruence statement. And that would be by CPCTC, or this would also be reflexive property of congruence if we liked. But we can say it using our corresponding parts as well. Again, make sure you define, explore, and geometry is easier in color.